All right, today is going to be a warm-up for being able to graph polynomial functions tomorrow. Today I'm going to show you some essential things that's going to help us get started with graphing polynomial functions tomorrow. So we'll have a little bit of a smooth transition as we go from what we're doing today to what needs to happen with the finished product of graphing polynomials. First thing you have to be able to do is find the x-intercepts. Remember, whenever I say x-intercepts, I'm also talking about the zeros of the function. I'm also talking about the solutions. I'm also talking about the roots. So this just goes all the way back to what we've done since August in here, is being able to solve these. So first order of business I'm going to have to do is set f of x equal to 0. Once I do that, I'm going to want to try to get this factored. Okay, two very big things you want to look for whenever you're factoring on the homework is first of all look for any common monomial factors, or we just call it a greatest common factor that you can pull out of every term. Once that happens, just look for binomials or trinomials that we factored back in the first part. Okay, set each one equal to 0 and solve. I think it's going to look very familiar to you. So let's try these together. So I want to find the x-intercepts of each polynomial function. Okay, so first thing I want to do is set it equal to 0. Okay, if you need to mark out the f of x, go for it. You don't really need that in order to solve this. So I'm looking for my first greatest common factor here. I see I can pull an x out of everything. I get x squared plus 2x minus 8. Okay, once I set that, equal to 0 still. So I pulled out the greatest common factor. Now, I'm looking at that trinomial. I see it will factor down into two binomials. So I split apart my x squared, x and x, and then two factors of -8 that add up to give me positive 2 are positive 4 and negative 2. Set each one of these equal to 0. And I get my three solutions, x equals 2, x equals -4, and x equals 0. So these will be the three places that it touches the x-axis if I was to graph them. Okay. Now g of x is kind of a special case right here whenever I set it equal to 0. It's already in factored form for me. So do not go through and expand out everything and then come back to right to where we started. It's already factored. So I can just set what's in parentheses equal to 0 and solve. So if I subtract 3 from both sides, oops, I get x equals -3. Or I can add 5, divide by 4, I get 5/4. Now, something special happens on this is I have it to the second power. Sorry, so that -2 or that +2 that's being raised to, that's something that we've been seeing this word on the last couple of homeworks called multiplicity. So this was a great movie from 1996. It was called Multiplicity. The idea is that these two were happily married. All right, well, the guy right here, he ends up getting really, really busy with work, with family life, and so forth. So he goes to this doctor, and he gets a clone, all right? They call him number 2. I think the guy's name's Doug. Well, Doug number 2 right here, he does all of the work. He goes and he's, I think, a contractor that goes out and goes to the meetings and goes to the work sites and so forth, while Doug number 1 can spend more time with his family and go out and play golf and do everything that he wants to do that's leisurely. Well, family life gets a lot busier, so they decided to make a Doug number 3. And so Doug number 3, they decided he would take care of a lot of the family stuff, the cooking, the prepping of meals, the getting the kids to soccer practice, and so forth. So Doug number 1 could still just go out and play golf and do everything that's fun. Well, then all of the clones decided to make another one. He's called number 4. and he was just a goofball that spent most of the movie running into walls and wearing obviously weird stuff. Kind of like when you make a copy of a copy, it doesn't really come out as good. That was the idea with it, they said. So as you can see, what they did was they took the original Doug right here, and they just made the same version of them over and over again. That's why it's called multiplicity. And that's actually a math term, meaning that it's the number of times a given factor appears in the factored form of the equation of the polynomial. So in other words, my zeros are going to be repeated as answers on this. So back to the problem we were just working on right here. And some extra arrows flying through here now. Get those erased. This -3 right here, well, all we know is that it is an answer twice, right, because of this 2. Well, instead of just writing it twice, what we do in math is we just say -3 has a multiplicity of 2. Okay, and then 5/4, since it's just raised to the first power right there, it has a multiplicity of 1. And so over here on A, all of these would have a multiplicity of 1 as well. We'll just kind of see that in the homework. Let's work one more together. Let's make sure we have it down. And so, again, setting it equal to 0. And most of these are going to have a GCF that you can pull out in front. Okay, so once I get that GCF, just for the ease of the problem, I'm going to pull this 2x down, and I'm just going to work with what's in parentheses right there. Anytime in math when you see 4 things in parentheses, 4 terms in parentheses like this one, it should trigger in your head factor by grouping. That is a very special factoring pattern you should have covered in your algebra class, where I group the first 2 terms together, and I group the last 2 terms together. So what I'm going to do is I'm going to pull out my greatest common factor out of that first group. After I do that, that leaves me with x plus 6. We pull out the greatest common factor out of the second group. I like it so the first term in parentheses is positive. So I'm going to pull a -4 out, and that leaves me with x plus 6 as well. Now, I'm going to do the greatest common factor one more time with these big terms right here. I see they both have x plus 6 in common. And if I write down what's left, x squared minus 4. I'm almost there. That x plus 6, it doesn't factor anymore, but the x squared plus 4, I'm sorry, x squared minus 4 does factor in the difference of 2 squares, x plus 2 and x minus 2. So if I said each one of these equal to 0, I get x equals 0. So subtract 6, so I get x equals -6. Subtract 2, I get x equals -2. And x equals positive 2. So this big old bulky equation right here would touch my x-axis 4 times. Like I said, that's the most important thing we're going to be doing tomorrow when we actually start graphing these. I just have to get these points down first, and it will make the rest of it go easy. So something else that will help is multiplicity. Okay, a little bit more formal, or I guess just more information about multiplicities in this top paragraph right here. Remember that this h right here is going to be my 0. All right, while this p right here will be the multiplicity. Now, how does this help me with graphing? Well, if my multiplicity is even, I'm going to simply just touch the x-axis. I won't cross it. So I'm not allowed to cross it. I can go up and touch it. I like what one of my juniors said today. He said it bounces off of the x-axis. I like the way that sounds because it's exactly what it looks like it does. If the multiplicity is odd, then we are going to cross the x-axis. We're going to cross the street, cross the axis. Okay? And so last part of your homework tonight, I'm going to give you some graphs. And I want you to talk to me about the multiplicities. So first off, I noticed that my zeros of this graph, I'm going to go through and list them. My zeros, remember, are just the x-intercepts where it crosses the x-axis. So that's going to be at x equals -3, -1, and +2. So to get the multiplicities of each one, what I want to do is I want to see if it crosses or touches. So I'm going to go to -3 first. -3, I'm definitely crossing the x-axis. If I cross the x-axis, that means I have to have an odd multiplicity. I think of the nicest odd number I can think of. Ooh, I like the number 1. I'm going to skip down to 2. At 2, here's where it just bounces off. Okay, it comes down, touches it, stays on the same side. If it just touches, the multiplicity has to be even. I think of the nicest even number I can think of, and that is the number 2. Now, something weird happens at -1. Okay, keep in mind the degree has to be 6. So if I add up all my multiplicities, I should get a total of 6. However, I see that it does cross it. So I'm first of all thinking odd number. But I have to go up a little bit higher than 1. Look at what this does right here at 1. It kind of snakes over it, right? Like a snake on a plane. If you go back and remember what our snake on a plane function is, it is x cubed, which is exactly the multiplicity of this one. I don't think you have any snakes or anything too high as far as the multiplicity goes in your homework. It's a bunch of 1s and 2s. But even this x squared right here should make sense. Look at that little parabola it made when it came down, touched it, stayed on the same side. So hopefully that makes sense to you as to it looks like the squaring function. All right, the last thing we need to do is in behavior. So I'm going to make up a couple problems right here. F of x equals 4x to the 6 minus 5x to the third minus 2x plus 3. Switch colors and do a g of x equals -3x cubed minus 2x squared minus 1. I've got some missing terms in there. I know that's not going to matter on this. And my h of x, let's see, let's do negative x to the 4th minus 3x cubed plus 2x squared minus 7x plus 1. Okay. So what I'm looking for on in behavior is how the graph is going to behave as it goes off the ends of my paper, or off the ends of my axis. Okay. For instance, well, first of all, I have an even column and I have an odd column. And then within each one of these, I have positive leading coefficients and I have negative leading coefficients. So the most important term that I can find on this is this first term right here. I'm interested in whether this leading coefficient right here is positive or negative, and I'm interested in whether or not this n is even or odd. Okay? And so from where I'm going to want to go from here is just being able to match to them. Okay? I didn't assign any homework on this, but if we can have this down coming in tomorrow, we'll be in good shape. So first up, I'm looking at this 4x to the 6th. So the big number in front, the 4, I see that it is a positive number. And then I'm going to look at the exponent up here. It's 6. It's an even number. So I'm going to go through all these. I'm going to search for where it's positive and even. Okay? And it matches up to this one. Well, if it's positive and even, tomorrow what we're looking at doing is the graph's going to come down from the top. It's going to wiggle around the x-axis for a while, and it's going to take off going back up to the top. Okay, how much does it wiggle around the axis? Well, it depends on how many zeros it has. We'll link all that together tomorrow. Let's look at this green one right here. This green leading coefficient is a -3. Well, -3 is a negative number. While the degree, the highest exponent I see this time is also 3, which is an odd number. So this time I'm going to come over to my odd column and find negative. So the green corresponds here. So whatever this looks like tomorrow, whenever we graph it, I know it's going to go up to the left and it's going to go down to the right. What it does in the middle, we got to figure that out after we piece it all together. You try the h of x, see where it points at. And I hope you got that h of x to point here. Okay, if you did, that is correct.